So we'll start now with naming hydrocarbon derivatives. When we mention the word derivatives, what do you have to keep in mind is that something is added into it. So it's derived from the hydrocarbon. So you have the hydrocarbon, and what you're doing is you're taking one of the hydrogens and on the hydrocarbon, and you are replacing it with something else. The first thing that we will see is the halogens, which are fluorine, chlorine, bromide, iodine, and astatine. Uh, so what do we have to keep in mind is that when we see hydrocarbon derivatives, we have to think about it as the functional group, which is atoms or group of atoms that are responsible for the chemical behavior, appears in the compound instead of one or more hydrogen atoms. So we have a functional group, or which is atom or a group of atoms. I will write this down and then show it to you. Okay, so hydrocarbon derivatives are part of that, very similar from the hydrocarbon, so that a functional group, and when we talk about a functional group, is nothing but an atoms or group of atoms that are responsible for the chemical behavior, appears in the compound instead of one or more hydrogen atoms. So we know when we have a hydrocarbon molecule, then we have a carbon, and then we have hydrogens here, hydrogen, 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 and so on. A derivative of this will be something like, instead of this hydrogen here, you have a functional group. You have either a halogen, and this is known as halides, or you have another functional group. Each class of so you have another one. So it's, let's say you have a chlorine, or you have a fluorine, or something like that. When we substitute that, what it is happening is that the hydrocarbon derivatives are known as the homologous series, and they differ between each other only by the number of CH2. So let's suppose that we have something like that, CH3Cl. Okay, so we have one carbon, and then in one of the, we have hydrogen, 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 and in one of them we have chlorine. Now, what is happening here is, in one of the instead of a hydrogen, what you see in the structure is, you see a chlorine. Then when you add more homogeneous series, what it is happening is you are adding on it a CH2 or CH3CH2CH2Cl. So those are known as homologous series, and the difference between them is that only the molecules are becoming bigger and bigger, but will behave in a very similar way because they all have this as the ending. Okay, so let's move to the first group of hydrocarbon derivatives, which is halides, which are part, as I said, part of the group 17 in your data booklet, which are fluorine, chlorine, bromine, iodine, and so on. So let's suppose, how can we name? This is the whole thing. So let's suppose that we have this as a structure: 1, 2, 3, 4, 5, 6. So we have 6 carbons, and at 2, and here we have methyl, and here we have chlorine. What each halogen is shortened by the ending O. So when we have chlorine, the root of chlorine is chlor, and what we do is we add an O. When we see a fluorine, if there is fluorine, then the root of fluorine, the word fluorine, is fluor, and then what we do is we add an O. And bromine, the root of it is brom, and what we do is we add an O. So this is what it means by when we are naming the halides. What we do is we add the ending of O into the root of the halogen. So let's suppose that we have this. Okay, let's start by labeling or numbering the carbon. We'll start so that the first branch is to the closest, is earlier possible. So will be 1, 2, 3, 4, 5, 6. And now we have 2 branches, methyl here, methyl here, methyl, and we have a halogen here. So now when we are naming it, chlorine is before, C is before M, so we'll name it as chlorine being on the 4th place for chloral. So this is what I meant by adding an O, ending O. And then we have on location 2 and 3, we have dimethyl. Why di? Because we have 2 methyl hexane. Okay, we'll do more examples in class for halides, but this is the gist of it. Now let's see how can we deal with alcohols, which is the other hydrocarbon derivatives, the second type of hydrocarbon derivatives. Alcohols are compounds that have OH, which is not the OH ion that you have in your periodic table, but it is the hydroxyl group. So it is hydroxyl group. So do not mess this up with OH that you have in your periodic table as hydroxide ion that you have. So it is a functional group. Okay, well, remember what we said at the beginning of this video, that it's a functional group, that it's responsible for the behavior of the hydrocarbon derivatives. Organic alcohol are not ionic and do not produce the hydroxide ion. Okay, to name the alcohol, what do we do is we drop E. So if we have propane or ethane, then we drop the E and we add the position in which the hydroxyl group is along with the OL. So pos location of OH and add OL. Okay, so let's see some examples on this. Let's suppose that we have something like this. Okay, we'll number the carbons. On this case, doesn't really matter too much as to how do we number it, from left to right or from right to left, because the branch hydroxyl group is in both directions, is at the second place. So since there are 3 carbons, then will be prop. So if we were naming it, it will be propane. Sorry, propane. But what we do is propane. Propane. So what we do is we drop the E and then we name it as prop. We add the location of the hydroxyl groups, -2, and we add OL. Propane to -2OL. We are very, you probably have heard the ethanol. So ethanol is with 2, is carbon, and then what you have is in one of them you have the hydroxyl. And then on the rest of them we have hydrogen. So in this case, doesn't really matter which one is 1 and which one is 2. This is just named as ethanol. So if it was just all hydrogens without the hydroxyl group, it will be ethane. We drop the E and we add ethanol because there is no point to have a number here. Now, this is when we have single, this is the rule when we have one hydroxyl group. But if we have multiple of hydroxyl group, then what we do is we save the E that is on the main chain or longest continuous chain, and then we add the location of the hydroxyl. So let's suppose that we have something like this, 1, 2, 3, and then we have one OH here and one OH here, let's suppose. Now let's start by naming or labeling the carbon. We will follow the same rule as to the branches are at the closest number, so it will be 1, 2, 3, 4, 5, 6, 7, 8. So the rule when we have only one hydroxyl will be to drop the E. On this case, we will not drop the E, so will be octane. So we'll save the E because we have multiple hydroxyl group, and then we will state the location of hydroxyl group. So will be 2, 4. Since we have 2, we'll go di to indicate that there are 2, diol to say that we have hydroxyl group there, or alcohol. Okay, the third hydrocarbon derivative that we will see how to name is known as the carboxyl acid. Carboxyl acids are organic acids, and they are, as a part of them, they have carboxyl group. Functional group, of course. Functional group. What is a carboxyl group? It consists into a carbon uh, uh, with oxygen, so carbonyl group, and a hydroxyl group. So you have a carbon that has this is known as the, I will write it here, carbonyl group. And the other one is hydroxyl group, the one that we just saw even on the previous one, hydroxyl group. And when we combine those two together, what we will have is something like carbon, oxygen, and OH, and then carbon is connected with the other one. This group is known as the carboxyl. So you're taking carboxyl and then you're combining them together. Naming them, well, first of all, the carboxyl group will be at the very end of the structural diagram for organic acids. For this particular organic acid, those particular organic acids will be at the very end. So naming them will be dropping the E of, let's say, methane, then dropping the E, and adding O, dropping E, and adding OIC, oic acid, of course, to indicate that you are dealing with an acid. So if we have, let's say 2CC, and then here we have carboxyl group, functional group here, then we'll name it starting with, or we'll number it starting with the functional group closest to the numbers, which is always at the end. And now we have, if this was just carbon and hydrogens on it, then we will say it's ethane. So we'll drop the E, and then we'll add OIC acid. So this is ethanoic acid, or in other words, is vinegar. Okay, so let's suppose that we have now something like this. When we have 1, 2, then we have a line diagram, is this one here. So let's number the carbons. This is a carboxyl group, functional group. So will be 1, 2, 3, and then we'll have, it's always the first one is start with that, numbering the carbons, and then we'll have propane because there are 3 carbons. So will be propane. We'll drop the E. We'll add OIC and acid. So propanoic acid. Okay, we'll do examples like this in class as well. Okay, so the fourth group or subgroup of hydrocarbon derivatives is esters. Esters are the smell. Okay, simple esters have pleasant odors, like when you smell a fruit, a banana, an orange, or an apple, anything. When you smell it, it is as a result of esters. Esters are derived from the reaction, so derived from reactions between carboxyl acid we saw what carboxyl acid is, like carboxyl acid and acid and alcohol. So what will you see will be this process. First of all, this process is known as the esterification. And what is unique on this, we'll see in difference with the carboxyl, but we just saw it here. Carboxyl acid will be this group, functional group, who will be in the middle. So we'll have something like this. I will draw it and show it to you. So you will have something like this, where this the ester part will be in the middle. We have hydrocarbon here and hydrocarbon here, and in the middle is the functional group. And as you see, even from here, the group is CO. Okay. So this will be the ester. Okay, when we are naming, the alcohol name is given first as an alkyl group, followed by the acid. Naming the acid, drop the IC and replace it with AT. Okay. So we'll see more of the last part of this part here when we talk about the reactions, but just so you know. So we said that ester is derived from a reaction with a carboxyl acid with an alcohol. So an esterification reaction, or a reaction that in which ester is produced, will be something like this. I will write it here and then talk it over to you. So we have an formic acid or methanoic. This is methanoic. Methane. So we drop the E and then we add OIC. We mentioned that in this video. Acid is reacting with ethanol under the presence of very concentrated, very high molarity of acid. Okay, so this is what is happening, the process, what is happening here. So even we said it here. Okay, so it is carboxylic acid and alcohol. So we have a carboxylic acid here, carboxylic acid. And we have an alcohol here. We'll talk about this even more when. So what is happening here? This hydroxyl group is reacting with one of the hydrogens of the alcohol to form water. So we'll have water. And then this, where should I use this one here? Green. Okay. And then this oxygen is replacing the hydroxyl group. Okay. So now what we have is COO group. Okay. So we'll have a COO and then we'll have the ethanol group here. Let's see. Okay, so now how do we name it? Naming it, I even mentioned it. So the alcohol name is given first. Name is given first. As an alkyl group. Alkyl group. Followed by the acid. Okay. When naming the acid, we drop the IC and replace it with ATA. ATE, not ATA. So here in this case, we'll start with alcohol. The alcohol is ethyl. So this is how we'll name it, ethyl. We'll start with alcohol, ethyl. And then we move to acid, okay, followed by acid. The acid was methanoic acid. So we drop the IC, drop this. So it will be methano, drop the IC and add 80. Okay, so ethyl methanoate. Okay, we'll do more examples like this in class, and this concludes the last video on naming, and we'll move to the reactions and as well as the fractional distillation.